first, our particular entire session was divided into seven parts. Our entire session was divided into seven parts. So from part 1 to part 7. Okay. As part 1, so the part 1 will be core, big data. We will discuss about core big data, clouds, and its ecosystem, fundamentals. The first will be knowing about cloud computing, in relation to big data. First and foremost, so we will have this will be a simple definition, simple explanation. So coming to cloud computing, this cloud computing provides the flexible rent on demand computer power and also storage over the internet that allows companies to analyze huge data sets without spending millions buying their own physical servers. So as companies, instead of buying their own physical servers, they're going to spend for buying for their own physical servers, they need to spend billions of rupees for storing the huge data sets in their particular companies. So for this particular huge spending, so the companies come forward, like so companies plans to tries to opt cloud computing services. Why cloud computing services? Because it provides flexible, and if you want to, uh, it is this cloud computing. You're going to pay some premium amount. You're going to pay some premium amount. You're going to pay some premium amount, but after some time, your particular size, if you want to increase your particular size of your particular storage, so it will not possible for physical servers. So if you require the particular storage, definitely you have to buy additional storage in a physical form. But coming to cloud computing, so depending upon the demand, you can able to increase your storage, and even if you want to process the task, so for over there you have to buy own processors. But coming to cloud computing, even on the demand also you can able to increase your particular processor also. You can able to increase your storage also. So this is simple explanation about cloud computing in relation to big data. Now let's see this particular. Now let's see with this with respect to. Now let's see with respect to IT. So think about AWS, so which is stands for Amazon Web Services. So this AWS or any particular cloud computing services such as Azure. So AWS and Azure, these are the top cloud computing service providers. Okay. So for this AWS and Azure, the both cloud computing providers. So there will be a startup. There will be startup. This startup, uh, this startup has to spend millions of rupees for buying their own physical servers for computer power, or massive storage. Instead of having this instead of buying their own servers, they chosen they chosen to rent. They chosen to rent storage and processing power from from Azure or from AWS or Azure. AWS or Azure. So even we can able to for few hours if they want to, for few hours also the startup requires this particular storage or processing power for few hours only. Even for few hours also they can able to they run their services in the services in the AWS or Azure. Even if they don't want to use them, they can turn it off also. So it is not possible with own physical servers. If you buy those particular own physical servers, had to use them. So at any time you cannot able to drop from the you cannot able to drop using this particular physical servers. So at any cost, if you buy the physical servers, you can able to have to work on that. But coming to startups, if they don't want to want those services, they can turn off the particular services after their work was done. So now, now we will go to the second thing. Second one is the three V's and five V's of, of big data. Let me give a simple expression about the three V's and five V's of big data. So coming to big data refers to data sets. So big data is nothing but it refers to data sets which are so massive, which are so massive and which are complex. So like even normal softwares, even normal softwares cannot able to handle them. Okay, so such type of data sets we are going to call as big data. So this particular big data is going to defined by five E's. One is volume, amount of data. Another one is velocity, speed of data incoming. Next one is variety. So different formats like text, video, logs. So these are varieties. And versity. Versity is nothing but so truthful, trustworthiness, and cleanliness. And next value, the actionable insight gained. So this the big data refers to data sets. So that is a massive and complex. So that normal software cannot handle them. Okay, it is defined by volume, amount of data, velocity, speed of data incoming, versity, different formats like text, video, logs, and versity, trustworthiness or cleanliness, and value. The value is nothing but the actionable insight gained. Now we'll see with an example. So think of Uber. Everyone know about Uber, right? Think of Uber's platform. So they are like coming to volume. They will have millions of rides. They have millions of rides recorded daily. And next velocity. So it is going to continuously. It will seek for GPS updates. Continuously it is going to seek for GPS updates. So that will be streaming every second, both from drivers and passengers. So volume is nothing but amount of data, velocity is nothing but speed of data incoming. And next variety. Right, so for this same Uber, so we will have reviews in text. Reviews will be in text, and each one will upload their photos, right? For photos, we have profile pictures, each and every driver and passenger, and it will seek for logs also. Logs is nothing but GPS coordinates, and even PDF also. That is nothing but payment receipts. So these are three V's, and next V will be versity. So that's it is nothing but, so it will try to it will be filtering. Uber will be filtering out glitch glitch GPS signals. So there will be GPS signal. There will be glitches with respect to DPS, like GPS signals. There will be glitch for GPS signals. So there is a glitch for GPS signals. It is try to clean. It is going to make the application trustworthy. If there is particular glitches, it will filter those glitches or nothing but cleans those glitches. And next, value. So coming to value, so this particular Uber will perform calculating search pricings. So like with respect to Uber, like for morning hours, the price will be very less, or like will have high. So the price will be very high during morning hours, and coming to afternoon, when the office hours is completed, the price will be decreased. So this is nothing but, so this with this the Uber will calculate the search pricings. So dynamically with respect to timings. So calculating search prices dynamically for maximizing its revenue, or to maximize revenue. So it will try to dynamically maximize revenues. Next we will move to, this is about this is about 3 V's and 5 V's of big data. Next we will be moving to types of data. So like coming to types of data, we will have structured data, semi-structured data, and even unstructured. coming to structured data, coming to types of data, we have structured, semi-structured, and unstructured. Coming to structured data, the data which is the data which is organized into fixed rows and columns, where the data is organized into fixed rows and columns, that is going to be called as structured data. And coming to semi-structured data, so it will be a flexible data that uses tags or markers instead of strict tables. And coming to unstructured, the data will be there will be a raw data with no predefined format or organization. There will be no predefined or format of organization. Whereas in semi-structured data, they will use tags and markers. So instead of strict tables. So let us consider a e-commerce platform, like for example, Shopify. Everyone know the Shopify will be a e-commerce platform. In Shopify, so we have like coming to structured data. So an SQL, like there will be some SQL database. There will be SQL database table. So where in Shopify, by using SQL database table, they are storing customer IDs, names, and the credit card numbers. In structured data in Shopify, they will have a SQL database. In the particular SQL database, they will create a table. In the table, they are trying to store customer ID, names, and credit card numbers. And even they have semi-structured data also in Shopify. Coming to semi-structured, so they will create some JSON files. So there will be a JSON. There will be a JSON file. Okay, there will be a JSON file. Like this particular JSON file will be sent. They will send this particular JSON file via an API. So via an API, which is nothing but this is like this particular Shopify will have a front end and back end, right? So in front end to display the particular message. So from the back end, they are going to send the JSON file from the back end API. In this back end API, so it will be containing product distribution, product description. So with some varying features, some varying features. So coming to features, the product description will have color of a product and size, weight, weight tags, and that's about these are about structure, semi-structured. Now we'll see unstructured. See unstructured data. So in the particular Shopify, for each in Shopify application, we'll have products. We have products, right? We will display products, right? So in each and every product, there will be have product reviews. So we will ask the customers to give product review, in form of text. They can able to give a byte. We'll have like a product review videos also, and like if they have, sorry, if they have, sorry, if they have customers, if they are having support from customers, they will have customer support audio also. We try to record customer support audio also, and will be recorded and will place in the particular application. And even we can able to share some promos also. So we will make that customers to download a product promo PDFs also. So that's all for now. So we'll continue this session in the second part. So thanks for joining, and don't forget to like, subscribe, and drop your questions in the live chat in the comment section. So that's all for now. We will connect back.